I'm continuing building the autonomous ground rover, and in the previous video we added to our ground rover using USB port the ArduRover firmware, and also made an initial setup for ArduRover for our 4VD rover. So in today's video I am gonna use the battery pack 4S1P to power this rover for the first time. But before I will do it directly from the battery pack to the rover, I am gonna limit the voltage and the current with the ToolkitRC M7 to avoid any issues related to inappropriate soldering or joints or even bridges which is in the rover, but I don't know about them. So I will use this ToolkitRC, and let's start. In the ToolkitRC M7, in the accessibility section, we have this power function, and we have to proceed with this power function. So in here we have to set up 14.8 volts, 4.5 ampere. Let's make it little bit less, like 3 or even less, 3.7 ampere maximum. This is the maximum current which will be supplied to the rover, and when I press the start button here, it will power the rover with the voltage 14.8 volts and 2.7 ampere maximum. In case of any joints or issues in soldering, the ToolkitRC M7 will just restart, preventing the rover damage in this way. So my radio controller, Radio Master Pocket, is ready, and rover is connected here. The battery also is ready, so I'm gonna start it now. Okay, we see that the flight controller is functioning. Express LRS also binded or not, we can look in here. Express LRS, and in the right top corner we can see the C symbol, so it means that it binded here, and it means that everything is okay with soldering, and there is no any inappropriate joints for now. So the experiment is successful. As experiment is successful, so I'm gonna stop this process, and we will see that the voltage also stopped.
Telemetry lost.
telemetry lost. So after this, I'm gonna reconnect the rover to the battery pack directly. The next step is powering the rover with the battery pack directly. I fixed this battery on the rover with this, and also made it little bit up on the table, because I'm gonna check this with the arm disarm, and if the wheels moves to the wrong direction, it must be in stable position on the table. So I'm gonna now connect this to the battery pack. So I have successfully connected the battery pack to the rover, and as we can see, it's functioning, and the ALRS receiver also connected to the Pocket, Radiomaster Pocket radio controller. So at least this is good, no smoking here now. So it's the first step just. Now I am gonna put it into the neutral position, and with this button it's arming. Nothing. As you can see, I'm moving the throttle, but nothing in reaction in wheels reaction. So let's investigate it. So I have investigated an issue. One of the reasons why it was not able to arm and disarm was the calibration exactly. So I forgot to calibrate the vehicle, and to do so I did the next steps. I went to the setup tab, and then selected the mandatory hardware in here, and then accelerometer calibration, and calibrated the accelerometer. Then also I made a few changes. I discussed this issue with ChatGPT, and it suggested to set up arming skip check equal to 1 and log backend type equal to 0 to eliminate checks for arming and sensor lost for now. And issue went out. So for now I can demonstrate in here. If I press this button, even if the sensor lost, so this button configured to arm and disarm when it pressed, and we see here the green color. So we also can see that it's armed in here, and in our messages we can see that it's armed. So I can move the vehicle because there is no energy for now, not enough, but I will do it later. So as you can see, in here. The rover powered on with the battery pack now, so it has enough energy to move on. And I will use this radio controller to arm it up. So now so the second attempt to arm the rover here, and so as we can see, rover can be manually controlled with a radio controller. Can even turn and yeah, so looks like it works for now. But it doesn't mean that this rover is autonomous now. It's not autonomous. We just created the rover which can move on with the radio controller, but we have much ambitious goal to make it autonomously controlled with the computer vision and Raspberry Pi. Let's build it further. Let's continue to build this further.